Here we are again with this question of x first, y first. I know it's exciting. Which way do we want to do it? Now, in this case, this region actually works out pretty well either way. Right? If I want to go y first, I have a nice function of x down below up to a function of x up above, and it's the same function throughout the region. If I want to go x first, I have a function of y on the left to a function of y on the right, and it's the same function throughout that region. So it actually works out really nicely. Let's see how that works. This is x equals 2y if we want to write it as a function of y instead of as a function of x. Let's see, this point here, that's 0, 4. I think everything is labeled that we need. So one way we could do this, is e to the y squared dx dy. If we want to do it x first, then we want y as a function of x first, we would want x to be 0 on the left up to x equals, what is this function? 2y on the right, and y is going from 0 to 4. And the other way we could do this is y first, and if we did it y first, e to the y squared dy dx, if we do it y first, then we have a function y equals x over 2 up to y equals 2. And I knew I did something wrong. That's a 2 in the upper end point here. Y is only going up to 2. Something felt wrong when I was saying that. Okay, feel better now. And x in this case is going from 0 to 4 for the x first case. So we have it as an x first or y first, and either one of these seemed equally easy to set up. But there's a problem, right? And the problem is we don't know how to do all of these integrals. We don't know the integral e to the y squared dy. We just know substitution, integration by parts. None of our techniques are going to work. That function, e to the y squared with respect to y, actually doesn't have an antiderivative. So we can't do this y first, even though we can set it up y first. We can't do it y first. But we can do it x first. If we do it x first, if we go x first here, then we have this, the derivative, thinking of that integrand, y is a constant, there's no x in there, so the integral there just becomes x e to the y squared from x equals 0 to x equals 2y. Then we'll have our dy, and that's going to be integral from 0 to 2. We plug in our values. That's going to be a 4y squared e to the y squared. And plugging in the that's wrong, sorry. Plugging in x equals 2y, this is going to be 2y for x. Sorry, e to the y squared. Plugging in a 0 for x gives us 0. So this is what we're left with. Now this we can do. This is integration by parts. No, it's not integration by parts. Wow, I'm screwing this one up every which way. This is a u substitution. We let u equal y squared, and the u substitution works out here. So this is an interesting example because you could do it x first, you could do it y first. Geometrically, the picture, the area is fine either way, but the function we're integrating actually matters here. We can't do it y first, but we can do it x first, and so we have to do it x first. So this is an example where the actual function we're integrating dictates the order that we have to go in.